Hello, everyone. Welcome to this ETSI webinar. My name is Nathalie Guinet. I'm working in the ETSI events team. And today we have a webinar on enhanced network automation and optimization of ETSI TeraFlowSDN. So this is going to be presented by Ricard Vilalta, who is the ETSI Software Development Group TeraFlowSDN Chair. Hello, Ricard.
Hello, good afternoon.
We have Lluis Gifre, who is the ETSI Software Development, sorry, I'm trying to practice the acronym, Software Development Group, TeraFlowSDN Technical Steering Committee Chair. Welcome, Lluis.
Very good. Thank you.
Yes.
Welcome.
So we have 75 minutes to go through the latest improvements of your specs. And this webinar is recorded and will be available on demand. And as live attendee, you have the possibility to ask questions in the question box on your platform, and we will address them at the end of the webinar. So now I will leave the floor to the experts, and I hand over to Ricard. Thank you.
Thank you, Natalie. So we had a previous webinar in December on release 4, and now we are happy to do this webinar to give you an overview of TeraFlowSDN release 5 new features. We have titled this webinar Enhanced Automation and Optimization with TeraFlowSDN. And the reason of that is because we have done significant improvements in that direction. So today, as Nathalie has said, we are, it's myself chairing the TFS and Lluis chairing the TSC of TFS, who will be presenting. The agenda for today is quite packed, so we need to move quite fast in some topics. We will try to address why we are doing TeraFlowSDN, what are the new release 5 features and use cases that we are supporting. I will be giving some more depth analysis on the network, enhanced network operation and optimization support for TeraFlowSDN. And then Lluis, I will handle to Lluis, which he will be detailing about another of the most significant features for release 5, which is network slice controller. Finally, we will have a demo, and we will have some Q&A session, as Nathalie has explained. So feel free to drop your questions during the session, and then at the end, we answer all together. So I hope that you enjoy, and let's keep it starting. So it's clear that network operators need automation, and network automation is a mean for having resilience in the network, for having and for this automation, we need softwareization to handle the network complexity. To handle this kind of complexity, we need to handle these multiple network equipments and domains. And typically, you see there are specific domain solutions that can automate the network. What we want is to have this network automation framework that helps all the operators to automate the network and to ensure resilience in the network. We're developing an open source cloud native SDN controller that enables smart connectivity services for future networks beyond 5G. That's our leitmotif, and we are moving towards this framework that you will see that we are presenting today as in release 5. The architecture for this release is quite complex. We have on top of our classical SDN controller, you see a new component, which is network slice controller. That's a brand new feature that we will be talking about it later, but it basically fits the network into the 3GPP wall. The IETF slices are translated towards the needed connectivity services that TeraFlowSDN is able to handle. Then you see that the service mesh and the Kafka bus that we introduced in the previous release. This is the significant change from the last 2 releases that helps us to improve the architecture for TeraFlowSDN, that helps us to improve the pipelines and the data flows that are happening inside TeraFlowSDN. So we are able to provide a better and faster response for telemetry, for example, and for monitoring data. This is very important. We have been working a lot on this cycle of analytics, telemetry, and automation policies that you can see on the right side. Other components that might appear new are, for example, the 𝗁𝗲𝗃. That this is something that we presented in release 4, and we are stabilizing in release 5. Also, the anti-gateways and so on. So let's see how we position in our perspective in an end-to-end network orchestration. In this case, you can have multiple flavors of TeraFlowSDN. You can have TeraFlowSDN being the SDN controller for an IP network, where we are able, for example, to control white boxes. We can have TeraFlowSDN instance being able to handle optical devices, and then we have the optical SDN controller. We have also a flavor of TeraFlowSDN being able to handle end-to-end connectivity services. This is the orchestrator domain, typically on top of IP plus optical domains. And also one of the last flavors that it doesn't appear in the figure, but we have also introduced is the one related with 𝗁𝗃𝗃 control. This is something that also TeraFlowSDN is able to do. We relate with other ETSI SDCs at the moment, like OpenSlice and open source Mano. We have been collaborating with them in order to have a seamless transition between the service connectivity that is requested from OpenSlice or OpenOSM and the deployed one. So, which are the benefits of TeraFlowSDN cloud native design? We claim that we are the first SDN controller that's cloud native. So we have a microservice-based architecture. We can horizontally scale. In this case, we can handle also massive data streams. We can ingest, process, and analyze data in real time. This is one of the benefits of this ability to scale. So we have also autoscalable and resilient components. This means that the Kubernetes-based deployment makes autoscalable and resilient. We're able to upscale and also restart components in case that they have some issue. And we have flexible and easy deployments. We have this containerization, which makes it more flexible across the edge, core, and cloud domains. So we can have several flavors and deployments of TeraFlowSDN. You don't need to have all the different components active, instantiated. You can have the bare minimum depending on the scenario. So we are also collaborating with other communities. So in the community of open source, we are relating with the different ETSI SDCs. You can see open source Mano, OpenSlice, OpenCapif. We have started a relationship with them. We have a strong collaboration, also done some proof of concepts between them. Also, from us, it's very important to be a reference implementation of the different requirements that operators have. That's why our members of TeraFlowSDN are part of industry organizations, and they follow the Telecom Infra project, for example, and OpenConfig, with this aim to align standards, to help interop events, to help to evolve industry towards the same goals. And this is also why we are part of the standard defining organizations. We are contributing to POCs there. We have some work done in ETSI IEC, in ETSI IEC Fix 5G, for example, and also the Zero Touch Service Management IEC. We have been contributing with them in the last few years. Also with IETF, we are following some of the TIA's ACTN models and also quite active at CCAM level. Finally, for the optical SDN controller, we are also implementing the Transport API from the Linux Foundation Omni project, and we are also contributing towards the handling of P4 switches inside TeraFlow. We have a strong ecosystem consisting of different organizations, SDOs, and also with links with the research community. In this figure, in the right side of TeraFlowSDN, you can see the different communities that research projects that are European, national, international, that are somehow feeding all the new features of TeraFlowSDN. So TeraFlowSDN has a lot of contributions, and some of them are acknowledged by these research projects. So you can see them, for example, 𝗥𝗲𝗄𝗃 being the major flagship project for 6G, and we have also, for example, Acros, Proteus, FlexScale, Season projects, and so on. So now I would like to talk a little bit on the new features of TeraFlowSDN. We have just released, and we think that we have now settled some new features and very interesting, and also use cases that might be of interest of the community. So we are doing this webinar to educate everyone to what can be reached towards using TeraFlowSDN. So as I mentioned before, TeraFlowSDN Release 5 includes the IETF-defined network slice controller. This is a significant contribution from Telefónica, as Lluis will later explain. It streamlines the process of orchestrating network slices from initiation to implementation. So the network slice controller is available. We have created a new module development group inside TeraFlowSDN in order to focus on this development. And also, it is a module that can be run as an independent component, or it can be run together with TeraFlowSDN controller. So it supports both ways, and we think that it can help the community to implement the different interfaces defined by IETF. Another of the highlights for TeraFlowSDN Release 5 is SmartNIC support. In this release, we have SmartNIC support, and we enable detailed context information management, such as the manufacturer's model, serial numbers, and transceiver data. This is significantly important in order to model the different network elements and the different network interface cards that we are supporting, which are SmartNIC, which are able to process packets on the same network interface card. Another of the features is the end-to-end service with in-band network telemetry, a major addition to TeraFlowSDN, which allows for real-time monitoring and telemetry in P4 data planes. This is crucial for dynamic network management and optimization, so you are able to proof the network. You're not able to only monitor network, but you're able to proof it, and this ensures streamless data flows and reduce latency for critical applications. This is also given together with enhanced telemetry and analytics. The TeraFlowSDN telemetry framework has been significantly enhanced with new backend collector functionalities, which are based on GNMI from OpenConfig. These enhancements support better integration of the network data, provides improved monitoring and analytics to optimize the network performance and reliability. As I will later explain, we have significantly work on the closed loop automation inside TeraFlowSDN. Another of the things that people were asking us from release 1 is the expanded OpenFlow support. We are happy to announce in this release that we have provide additional OpenFlow support. We have not reinvented the wheel. We have not implemented again OpenFlow protocol inside TeraFlowSDN. What we have done is to integrate a RIU-SDN controller and use its knockdown API, REST API, in order to provide connectivity support to OpenFlow domains. This feature it allows this streamless interaction with the different for the end-to-end orchestrator flavor of TeraFlowSDN, and it helps us to provide OpenFlow support domain. And then another of the features that we have been working is the zero-touch provisioning for white boxes, where we are able to configure and set up white box switches. This feature is very important for automating network provisioning. It allows the rapid deployment and management of network hardware with the minimal manual intervention. In this list, in this slide, you can observe the interfaces that we're able to support from the northern interface perspective and the southern interface perspective. I don't want to get into a lot of details, but please check the website because we are always improving this for every release. We always support new NBIs or SBIs. You can see, for example, that network slice service is supported with this inclusion of the network slice controller. And for the SBI, we support plethora of different SBIs. One of the things I wanted to show is the integration that we have been working together in a research project which is called ACROS, that focuses on having an open source stack for the telco edge cloud. We have a NETC-based solution that facilitates zero-touch multi-slice 5G deployments across the cloud edge continuum. You can see in here different domains, which are the core domain, edge domain, and corporate domain. We have TeraFlowSDN in this case to handle all the connectivity between the different domains and interacting directly with OpenSlice. We think that this is one of the significant contributions that we have done in the last years, and we wanted also to highlight it. So let's talk a little bit more on the topic of enhanced network automation and optimization with ETSI TeraFlowSDN. We know that you might be well aware of the different closed-loop automations and what ETSI ZSM is proposing for this closed-loop automation, where the network learns and optimizes itself autonomously. This is something that we are providing from the perspective of TeraFlowSDN to support this autonomousity in the provisioning and life cycle of end-to-end connectivity services. In this case, there are 4 steps. The first one in the closed loop is to observe. This means collecting, monitoring data, a lot of performance, faults, and etc. And that's why you have seen that we have been working during the last release in telemetry and monitoring components, which are key for this observation. Analysis helps us to analyze the data, to find issues, optimization opportunities, to have insights, and so on. Decision helps us to decide appropriate actions, and act makes us to implement them. So let's see with close detail what each of these phases is, how it is implemented in TeraFlowSDN. So in the observe phase, we have a component which is called the KPI management and telemetry. The KPI management helps us to define what to monitor, which are the important KPIs, from where to monitor, which are the endpoints which we need to use and to focus for more checking these KPIs, and to organize them and maintain the metrics. The telemetry component, it relates to how to monitor the different, which are the protocols that we're using, for example, CNMI, and which data streams should we consider. This is our telemetry component, the one that's taking care of this. And how we process, which are the streaming platforms, how we need to send them, and so on. Then when we have our data, we need to take a look at what to analyze, which are the input KPIs. So we connect towards the previous components. And then how to analyze them. This means to include new algorithms, new models. In the future, network digital twin would be also part of this analyze framework. And when to analyze, it's important also to focus on the timing and what to generate, which are the outputs that we want to generate, which are the expected KPIs from the data that we have received. So this is how the analytics component works right now, and we have been implementing this new release. Then we have to take decisions, and decisions are taken in TeraFlowSDN by the automation component. And in this case, decisions need to be taken into actions, which are how are you considering these actions. You need to update, you need to delete actions, you need to have them available at a certain event when a certain flag is raised, And what we need to do? We need to modify a connectivity service. We need to reroute, for example. We need to change a configuration in an IP router, and so on. So this is done by defining the different policies, which are then applied by the policy component. So decisions are taken into the form of policies in TeraFlowSDN right now, and then the act is to, in policy component, we react to the different policies that have been generated and we apply them. So this is how the closed loop works inside TeraFlowSDN. So you can see the different flows. As I have explained, this is more summarized. We have the monitoring data that goes from KPI management component and telemetry component into the analytics component. We have insights that are how the analytic it has consumed the monitoring information and is able to support the different policy validation, conditions evaluation, or machine learning algorithms that can be taken into consideration. Just to mention that the management and telemetry component right now support CNMI, OpenConfig, NetConfig, Transport API, and many other different connectors for obtaining this data. Then the decision is the automation component, which evaluates these insights and transforms that into policies. That's how we model this. And the act is the policy component, which executes the received policies to trigger the different network reconfigurations in real time. And after action, the system continues to monitoring to see the effect. This action resolves the issue. All this feeds back into the next cycle of monitoring. So this is how, for example, the ZSM automation service looks like, what we can do. This is the same service, and all these features are supported in release 5, which was released in April this year. So just to summarize a little bit these features, TeraFlowSDN is a cutting-edge SDN controller that has inside a closed-loop automation lifecycle to make networks more self-managing. It addresses modern network automation challenges by monitoring, analyzing, deciding, and acting in real time, minimizing the need for human intervention. This is as an open source cloud-native platform. TeraFlowSDN is continually improving through community efforts. So you are more than welcome to jump into TeraFlowSDN community, and we are well positioned to drive the future for autonomous networking. So I hope that you have enjoyed this first part of the webinar, and now it's the turn of to handle the talk towards Lluis, who is chairing the TeraFlowSDN Technical Steering Committee. So thanks a lot.
Thank you, Ricard. Yeah, in this second part, we'll go a bit in more detail on this feature of the network slice controller that Ricard was mentioning. But well, before that, it's always good to remember you that you have the TFS 𝗥𝗲𝗹𝗃 website that is the single entry point for the TFS community. There you can find well, requisites, guides, walkthroughs, tutorials, material from the hackfest, pointers to the repositories, contact information, everything. We try to keep this website updated, so in case of doubt, you can always point yourself to this website. Over there in that website, you can also make use of the documentation. So in the previous release, we were upgrading our documentation repository from the former wiki pages to this new, more enhanced documentation site, where you can have different, well, the updated documentations for the different versions, because we were having trouble with changes from one version to the other. Now you can review documentation for all versions. You have better and easier navigation means, including also a search engine. So we invite you to use it whenever you need it. And for sure, in case at some point you find yourself with some delta that you think is important, there are means for you to contribute. Okay, so just contact us and we can guide you if you want to contribute also to documentation. Besides that, reminding you also that in TeraFlow we are organizing a number of hackfests. These hackfests are aimed to be some learning material that you can consume at any time. We cover not only TeraFlow functionality and deployment strategies, we also cover more generic things like, for instance, network emulation, for instance, with Container Lab, specific data models, protocols, whatever. So feel free to consume this material for your purposes. The last one was Hackfest number 7. Yeah, you know, we were jumping one number. It's just for facilitating the numbering schemes here, so it's correct. And the last one was devoted to the network slice controller and all these things. I will provide you a very, very brief summary. You have all the materials, so if you want to go deeper in detail, feel free to jump in. And well, another interesting thing, if you join the TeraFlow Hackfest, you know, you can get some interesting gadgets and merchandising like the TeraFlow mug in last Hackfest. Take the opportunity to drink a bit, sorry. And well, going now into the details for the network slice controller. First of all, important, all this material, it's courtesy of Telefónica, Luis Miguel Contreras and 𝗿𝗲𝗹𝗲𝗀𝗲𝗹𝗃. Thank you very much for this very nice new component, and also for providing this material for the Hackfest that, well, we are reusing here. Just to introduce the team that is behind this network slice controller. As I mentioned, both of them are with Telefónica. Luis Miguel Contreras is the module development group leader, and 𝗿𝗲𝗹𝗃𝗀𝗃 is the main developer together with other developers at Telefónica. You can find both of them in Slack, so if at any point you have any kind of question related to the NSC, you have also channels in the NSC in the Slack that are devoted to the network slice controller. Then, briefly, what is network slicing? Because this is a common question that arises every time. So the idea is that in particular situations, you might need some specific connectivity services, for instance, in sports events, in concerts, maybe just in a public event, whatever public event. Sometimes it happens that maybe you need to stream material. Maybe you might have a huge number of users willing to share their pictures. At the end, whatever kind of connectivity that at the end requires some specific capabilities and characteristics. So that's the aim of network slicing. At the end, network slicing aims to provide customized connectivity services, fulfilling specific capabilities and characteristics. And well, that will be in summary what's this. Another point is that in terms of network slicing, there are few standards, and sometimes it creates confusion which one does what, where to use each of them. With this network slicing controller, you will see, I will explain in a moment, we are trying to clarify these things, okay? So we have the 3GPP initiative that defines the 3GPP network slices in their network resource management model. It is this TS28541. The point is that in these specifications, they cover management systems, they cover means for managing the radio access network, managing the core network, they define the different network functions and so on, but they leave a gap in between on the transport network. You see these dotted boxes for the transport network. So they don't really address the specificities of how to provide this connectivity. But in reality, come on, we need transport network. So the idea is that the IETF network slicing, it's able to provide this capacity of managing the transport networks. The IETF network slicing, it's based on the RFC 9543 specification, which is a framework for network slicing and network builds on top of the IETF technologies. And based on that, it defines all the framework that is needed. The good point is that this framework is not only for 5G and mobile networks, it's something generic, so it's very powerful. We can make use of it for transport networks. And at the end, it defines the network slice as logical partitions of the network that enables the connectivity between a set of software demarcation points with a specific service level objectives, expectations, and so on top of common underlay networks. So at the end, what we are aiming to do with this network slice controller is to bridge the gap between the 3GPP, that will be these systems on top, and also the SDN controller that is 𝗿𝗲𝗹 in charge of managing the transport network. A bit on the architecture. So the network slice controller, the network controller is the one that orchestrates the realization, the configuration, and so on of the network slices, the IETF network slices. It consumes IETF network slice service request on the northbound interface, and then on the southbound interface, what it does is to implement a set of connectors according to the underlay technologies that we can use. So, as I was mentioning, at the end, the network slice controller component somehow bridges the gap between the 3GPP and the IETF definitions of slices. The data model that we are using for the northbound interface, it's still under definition. That's why you will find it as draft on the IETF TS working group. Right now, we are focused on implementing implementing. There is implementation, but enhancing its version 22 on the network slice controller. In terms of the internal architecture for the network slice controller, this is the initial one. I have to say that we are pushing and elaborating this internal architecture in the community and together with the IETF. So, but in summary, and to do not complicate things that much, there is on top a mapper component that is the one that processes the customer request, putting them in the context of overall slices in the network. So essentially, it performs translations. And then we have below a realizer block that is the one that processes this definition that was translated by the mapper into a set of requests and actions that are forwarded to the underlying network controllers in order to create and set up the network slices. In terms of implementation status, well, as I was mentioning, this is a brand new component, so there are still many features that needs to be evolved, needs to be properly defined. But we already have the translator between the 3GPP and RM, the network resource management, slicing request into IETF network slice service requests. In terms of intent processor, we have preliminary partial implementation on the interface to interact with external planner components. That means you can, the component can offload to an external planner some particular details on deciding what to do with which resources. And the thing that it's pending is to perform the network resource planning and the mapping of these slices. So it's a work in progress, as I was mentioning. In terms of the realizer, it's pending the thing of implementing smart decision strategies to properly select which is the realization technology that needs to be used in each case. This is somehow hard-coded for now. It's something that was addressed in the last hackfest, but there is still work to be done here. But we have preliminary implementations of the realization technologies in this sense. That means the IETF layer 2 and layer 3 VPN connectors for the layer 2 VPN. Even it combines with the MPLS path selection, so it's it's ongoing. Besides that, and outside TeraFlow, as Ricard was mentioning, the network slice controller can be used with other SDN controllers. So in this case, for instance, there is preliminary implementation also with 𝗥𝗲𝗃𝗍 NE2. So it's a controller that supports the configuration of slices, involving also constraints in terms of delay, throughput, packet loss, and so on. This is just to illustrate that it's not only for the TeraFlow controller, it's also for other controllers, and you can combine. So you can combine scenarios where there is part of the network maybe managed by TeraFlow, other part, TeraFlow controller, other managed by third-party controllers. In terms of interfaces, well, I was mentioning the NBI, it's implemented. For sure, it will get additional improvements and enhancements, but it's usable now. In terms of the southbound, we have implementations, preliminary implementations, but the thing that it's pending, it's about defining service templates. So right now it's a bit, let's say, hard-coded, how the messages are, the request messages are composed for the underlying SDN controllers. So this is one of the focus of effort. The implementation of the 𝗥𝗲𝗃𝗃, in principle, it's mature and it's usable also. And in terms of the APIs, we are working on implementing the different typical CRUD methods for slices that create, read, update, and delete. Some of them are really mature, especially the creation, but others need to be studied properly, like the modification and delete, especially modification, because when you want to modify resource, some connectivity elements in the network, it's tricky. You need to manage things like the make before break or break before make, also, which is the side effects that you can have when you are implementing these changes. So it's not simple. This is focus of study still. And the database for persisting the changes, in principle, it's also mature. The component also features a web user interface. Right now, it's a web user interface that is isolated from the main TeraFlow controller web UI. This is because this is a different module development group. What we are focusing now and considering is on elevating the TeraFlow controller web user interface to a separate module development group, in a way that it can be consumed, or it will be able to be consumed by both the network slice controller and the TeraFlow controller. So that way it will serve as a single entry point, and we will not have to have two independent web user interface. As you see, the current one, it's functional, it works, it does its job, but it's still in initial stages. Okay, so we want to enhance this in order to facilitate the operator's life. Now, going to the demonstration, what I will do is to share my screen. Just give me a moment for sharing the screen, and then we go with the demonstration. Share screen. Okay, so now I'm sharing the screen. Again, this demo is courtesy of Telefónica. It's essentially a subset of what was demonstrated as a hands-on tutorial during the last hackfest. So I hope you enjoy it. And for sure, you have all the material available in the wiki pages and the page of the hackfest. So you can always go there, check the documentation, and read and try by yourself. If you want to run this demonstration yourself, what you will need is first a TeraFlowSDN controller instance that is up and running. That means you will need microKs version 1.29. This is nothing new. Besides that, you will have to deploy the network slice controller, which is right now a standalone Python application. The plan is in the next release to convert it into a microservice and enhance the way we deploy it. And in terms of compute resources, essentially it's the same compute resources you need for a normal TeraFlowSDN controller instance. So Ubuntu operating system for virtual cores, 8 gigs of RAM, and something like 60 gigs of storage. If you don't want to invest time in creating a virtual machine by yourself, we are providing a pre-built one for the hackfest, so you can always use it. And in this very same section of the hackfest page, you can find the rest of JSON files and the material that might be useful for you to reproduce the demonstration. Then, the first step for this short demonstration will be the deployment of the TeraFlowSDN. You will find that first we are checking that the pods of TeraFlow are up and running. Next, we will, well, if it's not running, you can always deploy as usual. So you have all the example files in the TFS 𝗥𝗲𝗹𝗀 folder of the virtual machine. Then we will check that the web UI is up and running and the network topology is pre-uploaded. So we did it that way to facilitate. So here quickly we are first checking that the pods are up and running. And also, as I mentioned, we are going to check now that the web user interface it's up and running and the topology it's in place. Oops. So the next step is the deployment of the network slice controller. In the NSC 𝗥𝗲𝗹 folder, you have the code. The first recommendation is to do a git pull to get the last version of the code, because it might happen from time to time that something changes. Maybe the community after the hackfest identify some new issue that raises some problem, whatever. So we try to keep the code updated so that the hackfest is still valid in the future. Start with git pull to get it updated. Ensure that you are in the right branch for getting the correct version of the code. And then we will activate the virtual environment and run the application. If at some point you find some issue like some requirement is broken or it's missing, whatever, you have here the command to collect the latest requirements. And at the end, you will see that we will be checking that we get access to the web UI of the network slice controller. So let's go ahead. The first point here is to clear. Here then we go, as I was mentioning, to the NSC hackfest. Here we already did the pull and so on. So we directly go to the Git branch to check that we are on the right branch. This is correct. And the next point is well, to activate the environment, as I was mentioning. And at the end, well, we just activate the application. You will see that now it's up and running. And in the web user interface, we refresh and we get the user interface. In this case, it's the Swagger with the list of methods that can be consumed. Okay, it's directly the Swagger because it facilitates. Okay, so going ahead, very briefly, I introduce a few details on the IETF network slice. Essentially, the template that we are considering for creating the slice. Essentially, we ask for a one-way bandwidth of 2 megabits per second and one-way maximum delay of 5 milliseconds. Besides, we request a slice with this name and description. We provide the list of service demarcation points. There we specify which node we want to connect with which other. The second SDP it's hidden for the sake of saving space, but you have the complete file in the material. And we also can define the match criteria like the VLAN tags that we want to use. We define the attachment circuits and so on with the IP addresses that might be needed. And at the end, we define which is the connection group and which SDPs are to be grouped in this connection group. Okay, all this is based on the specifications in the draft that I mentioned before, so you can check there. I go very fast here for the sake of saving time. Here we just upload the descriptor that I was mentioning, slice request in this case, and then, well, it will upload this file, execute, and we should get here confirmation. It's updated. We get the confirmation that it was created. Here you see that it reports the constraints, and then we go to TeraFlow. We go to services, and we see that the service was created, the one that is supporting the slice. You can check the details. In this case, the network slice controller decided to create a layer 2 connectivity service with specific characteristics that we were mentioning and the appropriate local and remote routers IDs. Here also we can see how to retrieve the slice that was created. You see here the identifiers, and in case you want to delete, you just go to delete, execute, and in a few seconds you get the slice deleted. Okay, as I mentioned, the delete, it's something that it's still work in progress. It works in some cases, not all. Okay, that finishes or concludes the demonstration. If you want to learn more on the TeraFlow, if you enjoy what you are seeing, you have a lot of means to reach out us by means of the web page that I was mentioning. We have periodic blog posts and news. You have the email addresses of the TFS support information. We have the TFS Slack workspace where you can find most of the members of the community, especially the most active ones. So in case you have trouble issues, you can always reach out to us and raise your questions. And for sure, you can consume the social media, and there you will get pointers of latest updates. If you are not a member of the community and you want to join, you are very welcome. You have instructions on our TFS 𝗥𝗲𝗀𝗃𝗀𝗃 page. And for specific institutions like SMEs, universities, public research, and so on, it's free of charge. So it's convenient. It might be convenient for you also. And if you want to stay tuned and learn more, I was mentioning, you have the social media, and also in YouTube, we have most of the demonstrations. And that concludes my part. I hand over back to you, Natalie.
Yes. Okay. So thank you for your presentation. So now we're going to go to some questions that we have received. So first question is, which capabilities in release 5 would you call truly new rather than incremental refreshments over release 4? And what concrete operator pain points do they solve?
Okay, thanks. Thanks for the question. I think that I will take it from here because Luis has been talking about a lot about the network slice controller. So I think that he needs some time to rest. So that's good that you asked this question because it's true that we have a lot of incremental features. Right now, the most important completely new feature, I would say, it's this network slice controller that we have just presented in the demo. But this is not the only one. And I would like also to express that although, for example, I was explaining that the monitoring, the telemetry, the policies, the automation components have had an incremental increase, an incremental feature. What they solve, the problem that they are solving right now altogether, it's a complete new feature. So the main pain point that we're able to solve is the automation to be able to monitor some network stuff. What's the bandwidth on some specific connectivity service? Which is the latency? To monitor this and to take decisions if these values doesn't fit what we expected. So this kind of automation that was not provided before in TeraFlowSDN, I would say this is a level 2 automation in the scale that TM Forum suggests. But this is completely new, and that's something that will be revolutionary for operators in order to provide more reliable services. I hope that this answers the question.
Mm-hmm.
Okay, thank you. Luis, you have anything to add, or you're okay with that? Yeah.
I think Ricard summarized it very well, honestly.
Super. Okay, another question we have is, which success metrics, not just adoption counts, will you track to decide if the project is meeting its objectives?
Okay, I will give it a try, and then you complement, Luis, if you like.
Please.
But adoption is key. But TeraFlowSDN is not a fully featured product which is stable for operations. Of course not. This is not our intention. We have people interested into bringing this to production, and this is something that is going to happen in the near future. But what we want for us is the adoption of the different standards that we are implementing. This is our key metric for us. So to be able to work in an interoperable world where we are part of the solution. We want to be the reference implementation of the different standards that are in our environment. For transport networks, you need to have a lot of different standards. You need to be compliant. You need to have interoperability between vendors. We want to ease this. This is a pain point in the operators side, and that's why operators are in our leadership group to help this to happen, to align the industry towards standards that are open and that are very easy to interact with.
Yeah. And if I can complement, I will say that besides that, for me, another metric of success, I will say, is that every time I go to some conference, some event, whatever, and I present something about TeraFlow, I mean, the coffee break discussions with people saying, hey, I like very much what you are doing. I think this is convenient. It's something that we need. It's good for sure for the industry, for the vendors, for whatever, for the operators. But come on, it's also good for universities. I mean, we have universities that are asking us, could I use TeraFlow for training my course, for giving my courses to my students? And that's very good. For me, that's a huge success metric, because it means people leaving, or students finishing their studies, they already know on TeraFlow, maybe basics, but they know they can reach the market, the industry, wherever, with some previous background. For me, this is a huge success.
Okay. Next question. How do you prioritize new interface support, community demands, standards bodies, or strategic partnerships? What's the priority?
Okay, that's an interesting question. I mean, this is something that you know that we are contribution driven. So this means that for us, it's like, okay, we try to adopt all the contributions from the different people in our ecosystem. All the members and participants of TeraFlowSDN are more than welcome to make contributions, and we try to land them in the next releases as soon as possible. That's something that we are not trying to impose anything. So in the case of the different members and participants that like to listen to the different community and also like to know about new requirements, of course, they are the ones that are taking the decisions. I would say that it's a balance between the three. So my guess is that mostly the interest is on industrial side. So this means that, for example, telecom infra project master requirements are key to decide to take decisions for the members and participants. That's something that we analyzed in a white paper a year ago on the different gaps that we still had for the requirements that the MAST was claiming. And that's all I can say, because we would like to have more contributions, and we would not need to prioritize them. I mean, the more the community is active, the more that we will be able to support everyone.
Yeah, and I think it's also driven by the different research projects that that we have that adopt TeraFlow, because they define use cases or maybe some specific features they would like to investigate, whatever, and they decide to contribute from time to time. So then it's also driven on their own interests, I will say. So it's as Ricard was mentioning, it's a combination of many factors here. It's not just one, in my opinion, also.
Well, as you were talking, we just got this one: how telecom regulator can contribute to make it easier to be adopted by telco service providers.
That's a very interesting question, because we have not looked in the policy side, but it's very important to consider. I think that the adoption of open standards is key from this way. I think it's very important that the legislator says that the different solutions adopted by the operators need to be open. And it's in this direction that we are working. We want to promote open standards. As you are seeing, we are implementing a lot of different northbound and southbound interfaces towards open devices. We support white boxing. We support open APIs. All this can be stressed by the legislator towards the operators. Operators, of course, it's on their interest to also adopt these measures, because it's on their interest to support this for multi-vendor opportunities. It's good not to be vendor locked in by an operator, but the legislator also needs to push this and enforce this. So it's a good win-win opportunity for everyone here to support open standards in this way.
Luis, you want to add anything?
I think the answer is pretty complete. I will not add anything. Thanks.
Okay. And are there mentorship programs or office tours for first-time contributors?
So I leave this to Luis.
Office hours, come on, 24/7, I will say, because it depends on the country where we are. We will reply whenever we can. I mean, honestly, I'm always inviting people to raise their questions whenever they have in Slack. That means it's somehow 24/7, in the sense that given that we have people from many time zones that are monitoring the Slack, are helping. I will not say from this hour to this hour. Just raise your question whenever you have an issue, and we will do our best. Typically, we try to reply as fast as possible. We understand that all of us are quite busy, have many things to work on, and if we reply fast, then we get faster contributions, and we are happy to have new features as soon as possible and facilitate the life of the community. So, in summary, if you have a question, just raise it, and we will do our best.
I would like
to
complement this a little bit. Please take a look at the documentation and all what's available, because we like also that if we answer a question, we like that this question is not asked again, because we keep quite a good documentation. So when a question is raised, if we point to the answer quickly, or we fix it and we also create a new answer for this, because I think it's important that also the community checks the documentation and read the manuals.
Yeah.
Let's say.
And search in Slack, in the Slack
Exactly.
workspace. Most of the questions are already replied. So take advantage of the issues of previous newcomers, let's say.
So that those links are given in your presentations, right?
For the Slack, yes, it's there is the link, and you can find it in the TFS 𝗥𝗲𝗀𝗃𝗀 wiki page with instructions for joining the community.
Okay. So I think we've covered every questions. People have been quiet today. Maybe they just want to go on holiday. It's the last webinar for this summer. So thank you for that. Thank you for preparing this work and presenting it to your audience. So this will be, the recording of this webinar will be available in a few minutes on the Brighton platform, and I will load the PDF of your presentation. So our next webinar will be early September. It will be on MEC on MEC, and we will be communicating on that on ETSI social media. So thank you for everything, and I hope you have some nice holidays soon. Thanks, everyone.
Thank you.
Thank you. Bye-bye.
Thank you.
Nice holidays.
Bye.
Bye bye.
Bye.